Thank you so much for coming along. My name's Bill Leahy and I am the Vice Provost for Student Staff and Civic Engagement here at Brunel. And it gives me great pleasure to introduce the public lecture series for 2019. So this public lecture series has been going now for quite a few years, and it's the opportunity for us to bring our brightest researchers and brightest academic colleagues, put them in front of you to talk about relevant, interesting, and we hope things that you will find mean something to you. Now, our theme for this year, I think, is probably relevant to all of us. Our overarching title is Our Digital Revolution Beyond Good and Evil. So this theme suggests, of course, that we've emerged from the previous revolution, if you like, the Industrial Revolution, and we find ourselves now in the midst of a digital revolution. And what's so interesting about this, perhaps, for many of us, is we were there before the digital revolution began, and we are actually living our lives through it. So dramatic technological advancements are offering hope in many ways for the environment, for communities and for individuals. And they give us lots of hope for the sorts of challenges that we face. But of course, these developments come hand in hand with threats to our online security, our traditional sense of what our communities are, and the infrastructures that we have become accustomed to in our lifetimes. So over the next 3 weeks, we will be contemplating these issues and exploring their significance to us, both at a micro individual level and at a meta level, shall we say. And so this evening, as I say, we've got 3 of our brightest minds asking whether, and this is the title for tonight, whether smart technologies and digital systems can overcome global challenges. We're joined by Professor Susan Jobling, who's our moderator. She's the founder and director of the Institute of the Environment, Health and Societies here at Brunel, and she's a professor of environmental toxicology. Oh, that's a bit of a mouthful, if you don't mind me saying. Now, her research regularly informs policy and has led to regulatory action, improving water quality and the health of aquatic life. Now, I'm going to introduce her. Before I do, don't worry, I will join you at the end of the evening to say a few more words. So if you can hold on to that thought. You know, if it's not as exciting as you're expecting, at least you've got me to look forward to at the very end, okay? And with that in mind, ladies and gentlemen, please join me in welcoming Professor Susan Jobling.
Hello, good evening. So global challenges. What are global challenges? These are major global threats to humanity, to life itself, to us, to the planet that supports us. They're also characterized by the fact that no one country can address these alone. No country, no organization, no institution. They need pooling and sharing of knowledge across institutions, disciplines, sectors, countries, even continents. These are things like hunger, health, poverty, energy, climate change, social inequalities. These are all challenges that affect us all to a greater or lesser degree. The UN has created the Sustainable Development Goals to address these challenges. Really what they are is they're a call to action to end poverty, protect the planet, and ensure that all people enjoy peace and they enjoy prosperity. That sounds good, doesn't it? Yeah. So if we could all enjoy that all over the world, and the goals that they have set are to be achieved by 2030. So there are a set of organising principles and effectively a set of goals that will help us actually develop as societies, human societies, so that they're focused on our economic development and our welfare, but at the same time sustaining the natural systems that provide resources, air, water, food, all of these things on which our economies and our societies depend. So there's a little video here, which is just an intro to what our three wonderful speakers are going to talk to us about. There's going to be a bit of an introduction to what these sustainable development goals are. Now at Brunel, we're actually looking at global challenges as well. We're doing that from a research perspective, and more recently we're doing that also from an educational perspective. So we host a very innovative new degree course. It's the first of its kind in the UK, and arguably globally. It's looking at how and why the world around us is changing. It's a degree that draws on the expertise of academics across Brunel, across disciplines, and putting together one holistic programme with different pathways. And that's a very exciting degree programme that undergraduates can do. It's quite challenging as well. But going back to today, so what new approaches can our digital revolution offer? And that is the topic our three speakers are going to talk about today. All of their talks, and many others in the series, are going to make great strides in responding to global challenges. Today we're going to hear three talks that are going to explore the sustainable benefits of 3D printing concrete houses. That sounds exciting, doesn't it? New technologies for reducing waste in the food industry, and the huge potential for innovation and scientific developments made possible through collaborations using open access networks. So we'll then invite our speakers back for a panel conversation on the three purple chairs. Led by your questions. So get ready to address questions to our three speakers. So our first speaker is the leader of the additive manufacturing technology, more broadly known as 3D printing, in the construction research group of the Department of Civil and Environmental Engineering. And the main area for his research is in using material science and innovative technologies towards achieving more sustainable construction. So please welcome me in join me in welcoming Seyed Ghaffar.
Thank you. Thank you very much, Susan, for the introduction. Good evening, everyone. It's an immense pleasure to have the opportunity to talk about this topic tonight. As Susan mentioned, the focus of my talk is construction industry, and how this industry is responsible for or contributes to a lot of global challenges such as climate change, global warming, resource scarcity. And at the same time, I will be talking about innovation, innovative technologies such as 3D printing and how they could offer some hope for global challenges. Construction industry is an important economic engine, but also one which consumes a lot of resources and energy. So we need smarter and more efficient ways of managing the resources. The current and modern construction sector is subject to a dramatic policy shift from a profit-charged business machine to a socio-economic and environmental sector. Three-dimensional printing is also known to revolutionize this sector. It truly has the potential to change the way in which the structures are built. It uses a combination of material science, robotics, computation, yet in some ways is not as futuristic as it sounds. So a good place for me to start is to show you again the 17 Sustainable Development Goals set by the United Nations General Assembly in 2015. And as Sue mentioned, they are a collection of 17 goals in the hope to transform our world, which is the Agenda for 2030 Sustainable Development. Engineers in the construction, the stakeholders, whoever is involved in construction sector can directly contribute to two of these goals. And that is to have sustainable cities and communities, and also to have responsible consumption and production. A very interesting point that I would like to share with you is from the United Nations. If the global population reaches 9.6 billion by 2050, the current global population in 2019 is 7.7 billion. So the projection for 2050 is 9.6 billion. If we reach 9.6 billion by 2050, we almost need equivalent of 3 planets to sustain the current lifestyle. So this says a lot about changing of attitude. And it starts from here, from all of us. All of us, we are in it together. We are all responsible for global challenges, and we have to change our attitude towards sustainable development and concepts of sustainability. Some other facts that I would like to share with you, and really this is a justification of the research that is happening in Brunel University, in the College of Engineering. 47% of all the UK CO2 emissions are linked to construction. Manufacture of construction products and materials accounts for the largest portion of these emissions. So therefore, if we start implementing more eco-innovative manufacturing methodologies, such as 3D printing, we are looking to bring that percentage to a much lower number. Another fact about construction is with regards to our waste generation. The construction industry generates about 35% of the waste to landfill. So these are just some of the problems in construction, and we need a solution. Circular construction is the solution. This is a concept that has gained a big momentum amongst the practitioners, the engineers, the scientists, academics, and it has more than 100 different definitions. But the most widely accepted one can be elaborated using the 4R framework: reduce, reuse, recycle, and recover. Circular construction would take a building component at the end of its service life and turn it into a resource for others. It will close the loop of industrial ecosystem and minimize the waste. And it truly has the potential to change the economic logic because it replaces the production with sufficiency. So reuse what you can, recycle what cannot be reused, repair what is broken, remanufacture what cannot be repaired. My developed model, and I should say that the current linear chain of construction is you recover your resources, your raw materials, you produce your building components, your building materials. After the consumption, they are treated as waste. And as I showed you before in the previous slide, 35% of that waste goes to landfill. So the circular construction concept is set up radically different from this linear chain of current construction paradigm. And at its core, you have the sustainable production, sustainable consumption, and recycling. I have developed this model for circular construction, and it starts from waste identification and source separation. Concepts such as smart dismantling as opposed to demolition. So stripping off the building components will allow you to recover more resources rather than the complete demolition waste. The very initial stage is pre-demolition audits. So we need to use innovation in this stage, such as building information modeling, big data analytics for waste management, 3D scanning. We also need to get robotic sorting and processing involved. They are more efficient. We must move towards mobile on-site operations. In order to reduce the carbon footprint of a demolition project, we can develop these processing machines that can be transported on site of demolition, and they can turn the chunks of concrete that is being demolished into a raw material, into crushed aggregates for remanufacture of concrete at the same site. The remanufacturing can also be done off-site. You have the Lego type construction methods. You take them on a new construction site and you assemble them later on. Another important thing about this model, the circular construction model, is to validate the three-dimensional printing. So to have or develop these robotic 3D printers that can operate on site. They can start printing your urban furniture, your building blocks. They have to have good reachability, and they must be on a mobile platform so they can move around as they are printing. In order for this concept to work, for the circular construction to work, we need to get the policymakers and the government involved. Currently, there are a lot of challenges in the quality management and certification. The very first one is that there are no standard way of testing a 3D printed block. Most of the developmental work that is being happening in the research institute is based on the ad hoc testing procedures. There are no standards for testing a 3D printed building block. If we are not able to test them based on the standards, how can we certify them, and then how can we implement it in construction? So this is the challenge. We need to get the policymakers, the governments, to become on board, to show them the potential of this innovative manufacturing methodology. And the key for the whole circular construction to work is to have flexible and responsive policies and regulations. They need to be responsive to the current societal needs. Another important point on this slide is that in recent years, the application of transformative technologies or disruptive technologies has presented a challenge to the current industry paradigms. They have also resulted in significant improvements in our technical capabilities, in output efficiency, whilst at the same time they have disrupted the established business model, the established practice. So many industries are facing an uncertain future in which today's technological limitations may not be assumed to apply. And construction industry is likely to be significantly affected by the application of transformative technologies such as 3D printing, such as virtual reality, such as nanotechnology. They are all presenting opportunities for our global challenges, but at the same time, there are a lot of bottlenecks that needs to be resolved before we can maximize the impact of these transformative technologies for the construction sector. So we have to transform the current long chain of construction and production using a holistic system that works. 3D printing is part of it, but the key to it all is automation in construction. Why can't we have automated plumbing, automated reinforcements? 3D printing is part of it, but automation in construction will happen and is already happening. 3D printing is not the answer to all the problems. It's an innovative technology which will be part of the automation in construction and will help us and will give us some hope for our global challenges. Ideally, we would like a system of manufacturing and producing construction houses that have no waste. There is a lot of waste in construction, and as I showed you earlier on, 35% of that waste goes to landfill. So these are just some of our problems that we are hoping by the application of technology we can overcome. The additive manufacturing itself uses a combination of robotics, architecture, design, and most importantly, material science. And I don't just say that because my background is material science. I think if material science is not optimized, the 3D printing will not work. Yet in some way, as I said, this technology is not as futuristic as it sounds. It's been the layer-wise fabrication has been happening for centuries. But now instead of layering bricks and mortar, we are printing it all in one go, layer after layer. And printable raw material or printable feedstock is a combination of bulk materials such as sand, clay, crushed stone, aggregates, mixed with some binders such as cement or a more sustainable option, fly ash, which is a byproduct. Sometimes the binder can be polymeric binders. There is also another important element to this material science for printable raw materials, which is called additives or admixtures. So these additives and admixtures are going to make a concrete or allow the concrete to have the properties to set faster, for example, to sustain the shape, to have a shape stability. So for the subsequent layers, so the subsequent layers can be deposited more rapidly. The focus of my research group, Additive Manufacturing Technology and Construction, is on the development of printable raw materials, and we have been successful in developing a printable raw material that works. The design formulation, we went through an iteration, a very long loop of testing for optimizing all the parameters which are involved in printing. And the main focus is on construction and demolition waste. So we are valorizing the concrete waste and other waste products, such as fly ash, which has cementitious properties. And in order to conclude, I would like to show you my circular construction model again. And very important point about this model is that if we set our targets low and we only focus on small wins, and by that I mean continuing the optimization of the current paradigms, we will miss on the big prize. We must inspire and encourage the engineers in the industry to be passionate about changing the mindset of stakeholders and general public. Most importantly, we have to show them the potentials. We need to open their eyes to the potentials of transformative technologies. And this needs to be driven through a combination of creative design, stakeholder collaboration, focused academic research, external industry engagement, flexible and responsive rules and regulations. This is the challenge. This is innovation in construction, a hope for our global challenges. Thank you very much.
Thank you, Seyed. That was a lovely presentation. So we're going to save our discussion until the end and introduce our next speaker, who is persistently working on a fundamental societal challenge, reducing food waste. There's an enormous amount of food that goes to waste. And also establishing a sustainable and food-secured society. He believes, so he tells me, that no one should go to bed with an empty stomach, wherever they live in the world. And that this is possible if we manage our resources responsibly. So please join me in welcoming Manoj Dora.
Today I have a gift for you, really nicely wrapped. But before that, I have a small question. How many of you would like to buy this carrot from the supermarket shelf? Kindly be honest. How many of you? Please be honest. Thank you. This is very nice that we have a very, I will hide it now because we have good takers here. But it took me half an hour to look for it and find a place where I can buy it. Could you guess which supermarket sells wonky carrot? Sorry? Morrison. Morrison is the only, okay, I'm not promoting Morrison here. So, but let's see how much actually we are aware of our food system. How much? So a very small question. Yeah? What is the percentage of food wasted of all food produced in the world? Please raise your hand if you think A. If you think B. If you think C. Good. If you think D. Amazing. So, the correct answer is C. So, sorry most of you. So, what is the percentage of people overweight or obese in Europe? Okay, it is before Brexit. So, raise your hands if it is A. Raise your hand if it is B. Raise your hand if it is C. Raise your hand if it is D. I love you guys. 4 people are correct. More than 50% of the people are either overweight or obese. Let's see this one. How many children in the UK do you think cannot afford or poor to have a healthy diet? Raise your hand if it is A, B, C, D. Again, I love you guys. It is 4 million. 4 million children. These are striking figures. And the more important thing is we don't really know what is going on. That is more challenging. So our actually global food system is broken. And let me give you some more examples what it means. What does it mean? So food waste, when you throw away food, this carrot normally would go to landfill. It will not be sold. And like that, millions and tons of carrots like that. When you throw away food, it's not just the resource, it's not just the food you throw. It's resources, labor, water. 1 piece of carrot, to produce 1 piece of carrot, we need 12 liters of water, fresh water. Yeah? Total food system, we need 70% of the whole water, fresh water we need for just to grow our food. Yeah? If food waste is a country, it would be the 3rd largest country in the world after US and the great America that emits the greenhouse gases. And we all know the impact and what it will have for our children. Yeah? Then, this is one of the very striking statistics I came across with. Do you know that farming has the highest suicide rate among all occupations? And we have 500 million of smallholder farmers producing most of our food, which is in developing countries. And they are at high risk, especially because of the climate change. There was a study, 1% increase in the temperature reduce 20% of their income. And they are at serious risk. Yeah? So this is another interesting fact. I don't know how many of you tried horse meat. I don't know, but but you were told that you are eating chicken or beef. So the food adulteration or food fraud is a very, very big challenge now. Do you know that we in the UK, the cost of this food fraud is £11 billion last year? And because of the complex supply chain, most of the food we are coming from abroad, and the whole supply chain is not transparent, and there is more likely that you have this kind of fraud or adulteration. So this is more and more clear. We have a broken food system, especially we throw away, as we saw, that 1/3 of all the food we produce. Yeah, it means we have almost 2 million people are obese or overweight. And the same story in the same side of the coin, we have 800 million people are undernourished or go to bed hungry. So how do you justify all these statistics? 800 million people are hungry, 2 billion people are obese or overweight, and we throw away 1/3 of our food. So we are in a serious problem if we don't realize the problem. Yeah? So do you think technology can help us? Especially, we are going through a 4th industrial revolution. Technology like 3D printing, Internet of Things, blockchain. We will discuss how we can, together, you and us, together all of us can fix this problem. So let's start with one small story. This is an interesting story. How many of you would prefer to have a steak like this? Freshly 3D printed steak. Would you like to have a freshly 3D printed steak now? Right? Because this was exactly the similar reaction we had some 40 years back when we had microwaves. Yeah, microwaves. Oh, this will be it will warm it up. This was the reaction. So let's see. But imagine that in a very harsh environment, yeah, where people are really hungry, and with simple 3D printing, we can eradicate hunger in those difficult places. So this is another very interesting story in Kenya. What this Kenya, the African Dairy Farmer Club, they created a Facebook group. Within 1 month, 120,000 farmers joined that Facebook group. Yeah, what they do, they share their information about their production, price, farming practices, all those things. And that company take out all the information from the user, brought together other information, weather data, soil data, the humidity condition, every data comes in. And in this place, they create the synchronize all the information and personalize the information, what the farmers need and how they can use it to make it more, more production or more profit, which market to take. So amazing technique, easy to use. It's called Internet. So Internet of Things combined with social media, combine all these data and help the poor small holder farmers in Kenya. Similarly, this is Daniel. Daniel is from Ghana, and the thing what you are seeing is he's spraying fertilizers on his pineapple plants, and exact precisely the place where the amount of fertilizers that plant needs. No more, no less, absolute precision with drone technology. Okay? This is one. This is, I say it, it's tracking the tuna from Fiji to Brooklyn. So exactly the minute the fish get into the container of the fisherman, it is tracked with sensor using IoT technology. It captures the quality, the quantity, the humidity, then all kind of information in one place, and you put it in the blockchain. It's a distributed ledger technology. Earlier, you and me as a regulator, you send the people and they verify and they write. So there is a chances of manipulation, chances of difficulties. That's why the horse meat scandal happened and all kind of adulteration happened. But when you do blockchain technology, there is no way you can change all those critical informations in the whole supply chain. right? So that's the simplified way of explaining blockchain. So this whole way of, you exactly can track the I'm still okay, right? Time-wise, yeah. So I'm tracking my time. So the whole chain is tracked. You exactly know where this fish comes from, how, and you can be confident that you are really eating tuna. Yeah. So this is another very interesting app. Have you ever have any leftover pizza you didn't like to finish it? What do you do with that? You order a huge pizza and you didn't finish it. What do you do with that? Huh? What do we do basically? We
Eat it the next day.
that's the excellent one. So by chance you don't eat it, what you can do? You can help me. So there is an app for that. You just say in your app that I have this amount of margarita, pizza margarita. Anybody in my locality would like to have it? Please have it. It's amazing. Some people say, oh, disgusting, what is this? Right? But if you can share your bedroom through Airbnb, why not your food? Right? So that's incredible revolutions coming in. The next stage. But these are stories. But technology only cannot really solve our problems. It needs a very concerted effort. It needs a multi-stakeholder approach. You, the general public, the researchers, the industry, the policymakers, we all have to come together to find all these different opportunities. And not just engineering or social science or the business. This is not how, like, we compartmentalize our disciplines. We cannot do that. We need to bring them all together. We have to sit together to find all these different interesting opportunities. Let's cut the emotion out of this whole equation. It's a huge business opportunity. How? Let me finally, to conclude that with the bigger challenge why our global food system is broken is we are traditionally living in this life of linear economy. We take something from the nature, we use it or we don't use it, or we make something, we use it, we don't use it, and we dispose it. It's a very classical model we are living our life with. For example, this carrot, we took it from nature, we didn't use it and we throw it because it doesn't look good. Circular is different. Circular is how each product, each stages, each design with how do we recycle it, remake it, redistribute it. So in each stages, if we can ask these questions, what are the different things we can do with this little carrot? Yeah, there are several things. But for that, we need to design our whole system like that. We need to find the right supermarket or the stakeholder who can use it or make it juice or I don't know. Carrot cake is delicious. So there are several different things we can do. So with this, I would like to, appeal to you all. Friends, by 2030, we need 2 planets to meet all our demands. Yeah? And by 2050, we need 3 planets. And its time is now. If we do not act together, our children will have problems. Thank you. By the way, this is very real.
Our final speaker he's the leader of the Modelling and Simulation Research Group in the Department of Computer Science. And he has led the development of multiple high-performance simulation systems in industry and digital infrastructures in Africa, so right there in the developing world. His work has had a very significant impact on industry, worth an estimated 5 million, and he has enabled digital services in over 10 African countries. Ladies and gentlemen, please welcome Professor Simon Taylor.
Right, hello everybody. Right at the beginning, Sue said that we can't do things on our own. We can't solve global challenges individually. And it's true. We have to do it collectively. Now, this is the point where I start explaining what I do to my mom, and she glazes us over completely. So I'm going to try and get this over to you. Now, arbitrarily, you are now the Americas. Okay? You lot at the back are Australia, you lot are Europe. I've got a special place for you at the front. Okay, we'll come back to this. Now, you're all promoted to scientists, and you're all interested in climate change. This is arbitrary. This works for a lot of different things. Now, let's say in the Americas, in Australia, in Europe, you've all got temperature sensors. You've only got your own little weather station, and some of you might actually have a weather station in your back garden. It's collecting data. Now, in the past, you keep that data to yourself. Now, as academics, we write papers on data and things like that, and we publish, but we can't do that anymore because we can't really solve global challenges if we keep things to ourselves. So you all share. Now, how you share, I'm going to talk about shortly, but let's pretend there's some magical way that everybody in the Americas, in Australia, and Europe can share all the data so that everybody else can see it. Now, we're all bright people, irrespective of being scientists. We're all very bright and creative. So we think, well, what can we do to that data? Well, let's say there's some clever people in Australia who've written some programs to analyze that data to tell us about climate change trends. Okay, so they think, well, actually, it'd be awfully useful if everybody could share that software. So they have a mechanism to share the software across the world. So more and more the scientists who have the data and have access to everybody else's data starts making joint observations and sharing. However, it's a bit slow. We're all very impatient. We like to go and make a cup of coffee and have our results back. So also, I'm now going to magically enable you all to share all your computers. So we're now sharing our computers, sharing our data, sharing our software to produce lots and lots of analysis. And very importantly, we then publish that in peer-reviewed scientific journals that are also shared. And those journals are almost like the lens to the data and to the scientific communities. But the point is, I can take that data, that software, that analysis, that results, and I can build on it. Now, the secret to that is all this lot, which says digital infrastructures or data infrastructures. Okay? Now, you guys, a special place for you, Africa. There is a huge creativity in Africa that isn't linked to this global community. And we are trying to change that. So this talk is going to highlight what we've been doing and how we've been enabling African scientists to join the rest of the world so we can solve global challenges together as peers. The outline, I promise you, it's good to share. Okay? I think I might have made a case that it's good to share. However, how do we share? And this is where I get told I'm the plumber. So the stuff that Manoj was talking about, very nice diagrams, but I'm the guy who makes it work. Okay? So if you need to make it work, come to see a computer scientist and we'll tell you how to fix your plumbing. I'm not fixing your plumbing. I know how bad it is. How are we using this to enable African science? That's what we're going to talk about as well. And then I'm going to give you some specific, brief examples of how we're helping. Okay, so it's good to share. There's been a change in the last 2 or 3 years, a big shift to open science. So I would say, before about 5 or 6 years ago, we didn't share particularly well. There were some large scientific communities that did, and I'm going to share one of those examples in a moment, but science across the board was pretty bad at sharing things. Now, we're starting to do more of this, and we're starting to be trained in how to share with good practice. So, for example, sharing data. Okay? I can make, this example I gave you, I can share data with you all, but I've got to make sure that data passes certain quality tests. Very importantly, I've got to make sure that data is interoperable. So that means I can share it through machines without having to do a lot of hand coding. which means I can start combining data sets to do inventive things rather than manipulating spreadsheets by hand and things like that. You want to throw all the algorithms and get those algorithms to do the crunching for you. We want to be able to share code, and in a similar way, we want the code to be a certain quality, and we want to be able to access that code in a simple way, because we have to bear in mind that not everybody's a plumber. You want to use the tap, you don't want to know how the tap works. So in a similar way to scientific software, you want to use that through maybe a web page as simply as possible and as fast as possible using transparent high-performance computing. And then, arguably most important overall, open access. I would argue that all the non-academic people in this room wouldn't be able to access any scientific papers. That's changing. Okay, there's a requirement for virtually every publication now to be published open access. However, that is not ideal and it's still difficult, but there are plans afoot to make all academic publishing completely open access. It's kind of thrown the publishing industry into a bit of turmoil. But together, we call that open science, and it's been recognized as a main driver to innovation and particularly a tool to solve global challenges. So how do we share? In my area, we call them e-infrastructures, and in the States, they call them cyber infrastructures. Generically, we call them digital infrastructures or data infrastructures. They link together sensors, computers, data sources. We talk about the Internet of Things. That's very key in there, so that we can track things like tuna, as Manoj sort of showed. There are really some amazing things going on. With open science, there's a reliance on open science digital objects. We use those to share. Now, that rather complicated diagram over there is what I deal with on a day-to-day business. All the scientists I work with just see a web page. All that's hidden. But those infrastructures do all the data interoperability, they do all the data sharing, they link the data together, they give us high-performance computing. But it's all there just to turn the tap on and get the power and the analysis as transparently as possible, which is great for people like me because I get to make lots of friends and new collaborations. The number of scientists I work with is phenomenal, and the number of interesting people I work with is phenomenal. It's a very exciting career path. Now, the largest of these is the Large Hadron Collider computing grid. The splodge diagram just above me is a truly worldwide computing grid where data is shared and computed every day. So we all know the Large Hadron Collider. It's up in CERN. It's generated it's a huge science experiment to slam together small things to discover fundamental properties of the universe. It's an amazing thing. For me, what's even more amazing is the worldwide computing grid that backs it up. It links 42 countries across the world. There's 170 computing centers. It runs over 2 million tasks a day. It has 1 million computer cores attached to it, and it has a storage of 1 exabyte, which is basically 10 with 18 zeros. It's a huge science experiment. Now, the reason why I'm saying this is rather like the Apollo program, because the spin-offs from this scientific endeavor in terms of plumbing are things that everyday scientists can use. So the core technology used behind open access repositories where data is stored comes from CERN. It's called Invenio. It's been upgraded to something else called Zenodo. You don't have to worry about that. But it powers open access repositories. There are plenty of other things that come from CERN which inspire architectures like the one just above me to create these worldwide data infrastructures. Now, there are moves to link Africa there. Now, that complicated map behind me is quite, whenever I see that, I feel incredibly exciting. About 10 years ago, there were no links to Africa. These are high bandwidth capacity links that are dedicated for science. Okay? So though 10 exabytes or 1 exabyte of storage or whatever, you can't put on the public internet so well because you probably notice a significant slowdown. So there are dedicated scientific links. There are brand new ones being linked between Europe and Africa. Okay, I was lucky enough to be part of the FEAST program's END, which was a feasibility study into joining Africa to the global scientific internet. That program became Africa Connect, and Africa Connect physically lays sea cables down the east and west seaboard of Africa. And what's exciting is Brunel, you'll see there's another logo there. That's the University of Catania, Professor Roberto Barbera, who's amazing. The two of us and various other people have worked with African institutions to say, well, it's coming very rapidly. How do we prepare for the services that you would need to bring all your thousands of universities and tens of thousands or hundreds of thousands of scientists into the worldwide community? So we've been preparing the way. And key to that are two organisations, of which I've got very good friends at. There's the UbuntuNet Alliance, which is responsible for national research and education networks in East and Southern Africa, and WACRAN, Western Central Research and Education Network, which is responsible for Western Central Africa. These are great guys to work with, and these are the guys who are the hubs to bring in the network capacity and expand scientific services to the 50 or so African countries that are, well, all of the African countries. So, this is coming to the end. You've been very patient listening to 3 talks, but I just want to dwell on this a little bit. These are some examples of what we've been doing. In a recent project, the SciGao project and the Tandem project, we worked with a lot of African stakeholders to create scientific applications. And here are some examples. So, Diana is a lecturer at the University of Dar es Salaam in Tanzania. She's interested in power grids in villages. So we helped her to create a science gateway to run simulations of different power distributions and strategies in the Serengeti. There were lots of other people we worked through Hackfests. If you're a computer science student, you'll be aware of Hackfests. We trained over 200 scientists in developing their own scientific software through Hackfests, and we're really trying now to find a way to get UK computer scientists and African researchers together to build even more. The amount of creativity is amazing. Another example is MyPar. So at Lagos State University, Professor Abisalara, he's created a piece of software that now allows you to scan brain images. He had nowhere to store them. He had nowhere to run the software apart from his own machine. So we trained him, and he created his own science gateway, which is called MyPar, which is running out of Lagos State in Nigeria. There is a voluntary donation scheme for people to donate brain images for the scanning software to learn from, so it can automatically identify brain tumours. Now, just to underline this, before, Ben just had a piece of software running on a computer. After, he now has a science gateway, so anybody in the world can access that software. So it's tremendously exciting. The map that you can see is an example of citizen science. Okay, now this was a straw man demonstration to show how, well, Africa always has big headlines about HIV and tuberculosis and malaria as being the big killers in Africa. Did you know, if you take away all the clinical reasons of mortality, biggest cause of mortality is motorcycle accidents. It's huge in Africa. The question is, where are the accident spots? So we use the same technology to pilot a demonstration in Kenya so citizens, through a mobile app, could identify where motorcycle accidents took place. And the idea is that that would help planners to plan for accident black spots. And that's got significant interest in several other countries because it's such a big challenge. The picture, it's a living lab in Sengerema in the middle of nowhere in Tanzania. It's a little dot in a very, very big country. A living lab, it helps entrepreneurs create new things. Now, that's the thing about Africa. It's huge, and it takes a long time to get from A to B. So, we demonstrated how you can use digital technologies to allow entrepreneurs to make a video, deposit it in a repository, and then allow other entrepreneurs to see this. We discussed the possibility of this with Professor Jobling in a worldwide plastic strategy, so entrepreneurs in Indonesia could come up with a clever way of recycling plastics and instantaneously share that across the whole of the Indian Ocean. So in that example, there was a guy who came up with a way of making boxes out of plastic bottles. He did it particularly well. He had a video, and through an open access repository, he could share that. And that technology is beginning to spread. Following on from that, this idea of having an open access repository, we've implemented in Ethiopia. So NADRA is Ethiopia's first open access repository for Ethiopian scientists. That's gone live, and we're now doing training to support them to onboard that for scientists across the region. And that idea is growing, and we're hoping that is going to be copied throughout other African countries in East and West Africa. And then finally, that sort of flowchart thing there, that's the roadmap for service development in Western Central African National Research and Education Networks. And that box there that you can see above me is exactly what I've just said. Open access repositories and science gateways. So we're training people in that region to, first of all, provide the infrastructure for that, and then actually train scientists to use it. And we have the world's first science gateway being deployed on African resources in Western Central Africa, and it's going live in March. And I couldn't be more excited. This is tremendous. It's really happening. Anyway, there you go. That's the end of my talk. And it's basically, you can't get anywhere without plumbing. Thank you.
So who would like to ask the first question? I actually see. See? Thank you. Thank you.
Hi, I'm very interested in the 3D printed brick. Have you got a sample?
Yes, yeah, we have printed boxes, building blocks, as we call them. Mm-hmm. And as I said, we are waiting for the testing and being able to certify these building blocks so that we can take it to the next stage, which is the pilot scale and then the demonstrations. But you know that there are a lot of demonstrations across the world, especially in Middle East, in America quite recently, the US Army 3D printed. But these are just demonstration projects. We cannot really have the full implementation because we can't certify them. So that's the challenge. Yes, so
construction industry, yes?
Exactly. So imagine in order to quantify the compressive strength of a 3D printed building block, there are no standards for testing this. So what we do in our labs is just like an ad hoc testing system based on the previously known standards. So we need, that's what I referred to in my presentation, that we need the stakeholders to come on board, to sit down, and I know quite recently that the talks are being started and some positive things will happen.
Correct me if I'm wrong, but I suspect that part of the solution for food waste is very unfashionable things like good road networks, efficient diesel engines, single-use plastic and things like that. Clearly not the total solution, but can it sometimes be a problem when there's a media position or a media bandwagon that develops around a technology that actually has a use but becomes unfashionable?
I mean, there are two parts, First of all, technology cannot solve the whole problem, right? It's a human thing. It's a lot of the problems. We had extensive study on this. Our behavioral change is really required to make this huge, change. The good thing is that things are moving in the right direction. We are more aware now, and also the campaigns and media really help us to get ourselves, to join that revolutions, and more also startups coming and business opportunity coming, new business models are coming. So to sum it up, that's what I wanted to also share with you, that we really need a multi-stakeholder, and from whichever angle or from whichever side we could save or we can prevent waste, that would be helpful. That's how I can see it.
My question is, how do you plan to insulate these concrete buildings? And then if it is being insulated with an oil-based insulation, for example, which seems highly likely to me, do you think that having concrete buildings with oil-based insulations is a sustainable solution? And what do you do with those insulations at the end of their lives?
So we have developed also in other projects insulation materials which are highly efficient and coming from the sustainable resources, such as VIP. I don't know if you know about the vacuum insulation, but it doesn't stand for very important person. It's vacuum insulation panels. So we can incorporate this insulation panels in a 3D printed concrete wall. So they can work together. We can incorporate a system, have a holistic system of a wall that has the structural load bearing, insulation, and then you can assemble them together like a prefabricated Lego type of construction on site.
What about the embodied energy?
These are some of the calculations that needs to be studied and looked at. The LCA, even the LCC is a big problem. We don't know if we are able to produce or manufacture 3D printed houses which are economically feasible. So as I said, these are all developmental stages. And now we want to make sure the technology works. And we should not worry about this at this stage, the LCA or the LCC, the life cycle costing, life cycle assessment. I think we should focus on the technology and make sure the technology works. If we only focus on optimization, then I think optimization is actually an impeding factor for evolution of the industry. So for us, the main focus is to make sure the technology works and we bring some innovation into the sector.
Yeah.
I was wondering if sometimes financial interests restrict access to open access to work.
It's interesting. When I give training sessions on this to scientists, you do get a polarized view. The majority in the room are happy to share. There's a smaller number who aren't, and the smaller number tend to be around pharmaceutical and drug discovery, so there is a vested interest there. But, it's one of these things. You can't make laws to share, that's not right, but you can give the apparatus to share, and I'm very happy to say there's very large networks like Elixir, which are full of biologists trying to beat cancer, and they share information all the time. And there's lots and lots of really good examples of scientists sharing things in a very mature way. But yes, when you get that overlap with, I could make a lot of money out of this, then yes, it becomes a bit more restrictive. But fortunately, most of science is a lot more altruistic about that, especially in terms of global challenges and sustainable development goals.
Thank you, Tom. And there's another one over here in the front.
So this is a question for Simon. I was just wondering, thinking about your plumbing metaphor.
Yes.
Why was the digital waste?
Say again.
Why was the digital waste?
So I did some work with some manufacturing companies, and we've got, I don't know if everybody, I'm assuming everybody's heard Internet of Things at some point, so it seems to be in the press all the time. So some bright spot usually says, well, that's great, we can link up a machine, we can get a constant stream of information about the efficiency of what that machine is doing, and we can use that directly in a model. At that point, I have to go to the dentist and get some new fillings. You can't use data directly very often. Data has to be cleaned. At the Large Hadron Collider, for example, most of the data is thrown away. It's cleansed, it's then put into models that generate even more data, because what we're interested in is probabilistic models that give us, in the manufacturing example, the probability of breakdown, the probability of efficiency going down, and that's based on sampling. So yeah, quite seriously, there is a lot of digital waste, but we're very good at eliminating that, and it doesn't have anything like his waste implications or his waste implications. I can quite happily say digital waste is recycled ethically, usually by clicking on the waste bin.
Thank you. There's another question. Is there another hand anywhere after that? There's another one over there. Yeah, we need to pay attention to the different countries. I remember we had Europe over here. I haven't had many questions from over here. Yeah, go ahead. Thank you.
Question on the plumbing side of things. You showed a map there with, you said you were constructing cables all the way down to connect up Africa into the network. I was slightly surprised about that. The original revolution in communication was laying no cable across the Atlantic. Signals went from A to B. I had a more sort of vision of beams going up to satellites and bouncing back out, sharing the data that way. Does the data sharing revolution depend on using more resources to build these huge cables?
It's interesting that, because the VSAT is the current main way universities in Africa access the internet. And this is a problem. Now, bear in mind, those lines are just scientific internet lines. There's tons of telecommunication cables going all over Africa. particularly fibre optic ones. But VSAT has been the bane of African academics' existences for as long as it came into effect. It costs a fortune because it's a big monopoly. Now, these are for universities to use as part of, you know, scientific progress and for students and things like that. And it's been part of a national resource, so it's effectively free. Whereas private satellites up there are not free at all. You've got to pay for the bandwidth, you've got to pay for lease. I mean, you know, you've all got cable, presumably. You know, you're paying for your cable, and when you sort of wake up one day and realise how much you're paying for it, you think, well, it'd be great to have that for nothing. And of course, nothing costs nothing. You know, this is part of the university infrastructure that we enjoy in the UK, but it's provided at government level, and because of that, we can do great things with students in science. But yeah, no, I do agree, you know, the satellites are there. It is changing, however. There are more entrepreneurs putting satellites up there and providing low-cost bandwidth. But these cables are specifically for scientific programs. One of the things I didn't say is in Namibia, they're building the central component of the square kilometre array, which is part of turning the entire planet into a radio telescope. And the output of that will be the equivalent on a daily basis of the entire output of the whole internet. And they're putting down extra cables to deal with that as we discover, you know, ancient secrets of the universe. But the point is about these big science projects is that they have a demonstrable link to advancements of science, particularly with the SDGs, and has an impact across the world. You know, but it's changing rapidly. In Africa, there's nothing like it. You know, as soon as you learn one thing, next week it's contradicted and new things come along. It's so exciting to work in that context.
Yeah, good evening. My question is this. I found your talk on the building project extremely interesting, pouring concrete. Okay, that is brilliant, or whatever it is. How do you get around sort of doors, windows, roofs? And also, what about the mechanics inside the house, like heating, lighting, plumbing, etc., etc. So you build this structure very, very quickly, but then you've got to put all the services in, or is that all done in the factory, or how is it done?
That's a good question. I think I touched on it, is automating the whole structure, the construction of the whole building. So why can't we have automated plumbing? Why can't we have these robotic arms who are dealing with plumbing? And then we have another nozzle on the same printer or a different printer who is printing the concrete, the wall. So we can have automated reinforcements. So it's all about the installation of the building blocks together. And I think this is the automation. As I said, I didn't want to put the focus of my talk only on 3D printing. It's a technology that will play its role. But the whole thing, the overall solution to the circular construction is automation. And it will happen. I'm very certain of it. There is no question about it. And it will happen. All these problems that you mentioned, the building appliances, they will be sorted out, and we will have robots, robotic arms, who will deal with the whole construction of the building, of the structures.
Like we build cars, I suppose.
Yes. Yeah.
Thank you. Justin.
It's a question for Simon. I was struck by your response to the question about financial interests. And I wonder if you think there's a risk with the rush to open data and open access of stifling innovation. So why would a pharmaceutical company spend 15 years developing a drug only for it to be produced just as cheaply by other producers? And indeed, why would we go with open access from a model where the library pays to where another part of the university pays, and actually stifle innovation in terms of the types of articles that are submitted?
But the way we operate is that we do science, we get our results, we write up journal papers, and we publish them in journals. There is a whole industry, a self-perpetuating industry behind that, who then require that if we want what we've published in their journals to be openly accessible, we have to pay for it. Now, there's this thing called Plan S that's coming very quickly, and it's mandated by government level. And that's basically saying, well, you're going to publish things completely openly. And the reaction from the publication industry has been a moderate panic. So there's basically, I mean, if you talk about open access and things like that, there's a community that says, we don't need the journals. And if you actually look at this and you think, well, with journals, a good scientific journal will have an editorial board consisting of volunteers. They will have peer reviewers that are all volunteers. You typeset the journal yourself. You usually send off to somebody else and then mucks it up and you have to do it again. But it's all volunteer based, and yet in the background there's these publishing companies. So the move towards complete open access, I think, is going to break that industry and break the monopoly. So the financial interests, I think, are, in that context, in a complete panic. But it is a major concern that you are paying to have publications in a scientific publication openly accessible, and ultimately it's the taxpayer who foots that bill, because you're funding scientific research and some of that money is going to some very wealthy companies' pockets. And just as a personal thing, I'm not representing anybody else, I don't think that's really good. You know, so I'm hoping that model will change significantly.
Good evening. I'm intrigued by your use of the word sustainable. I hear it, I see it every day, and I hear it here. Would you be able to define sustainable in each of your fields? It seems that if something is prefixed by the word, it makes it okay. How long is sustainable? Is it forever? It seems to me that sustainable development is a contradiction in terms. Can something be developed sustainably? How long is sustainably? It appears it was ushered in at the same time as digital technologies, and to my knowledge, its origin is in green issues.
So perhaps I could ask each of you first, you know, what is sustainable to you?
For me, it's an easy answer, and that is the materials that we build with. So the materials, the building materials, are they renewable? How fast can they be renewable? So the construction materials, the sustainable construction materials are the materials that will be renewed, and we can recycle them. They are easy to recycle. So when I refer to sustainability in the context of construction, I am referring to the construction materials, but they could also be in a system, a product. So that's the easy answer for me. Anything that relates to the construction and building materials and the sustainability means renewability of them. It could be agricultural waste products that you can turn it into a building component, or it could be recycling the concrete waste from the demolition site.
So for me, sustainability is not a time period thing. For me, it is a, initially, whenever we were making decisions, we were often economic driven or profit driven decision making. So sustainability includes actually at least three important dimensions to it. Economic, that is definitely a company profit making, and then social, it should be socially friendly or useful. Or third is ecologically friendly. So whenever we were making any decision or doing something towards that, we should be taking care of all these three elements, and then only we can say it is a sustainable objective: economic, social, and ecological. Thanks.
I'll go quite an easy one. Sustainable just basically means changing your mind. So one of the goals is zero hunger. The only way we're going to get to that is if everybody collectively changes their mind forever on how we're approaching this. And that, for me, is sustainable. That's it.
I grew up before plastic was used so extensively in packaging. Yes, there was sliced bread, yogurt and cream, but most of the food I bought was provided in paper packaging, even from the butcher and the fishmonger. The dichotomies that I see are that the globalization and technology developments have put us in a very skewed position regarding the food supply and the disposal of all this packaging. So all food packaging is now, and if you look in the supermarket, all our food packaging is now the responsibility of the local councils to dispose of, and I have no idea how they do it. The out-of-season foods are coming to us from Africa mostly. Kenya probably, is producing a lot of food for Europe and the Western world in water sustainable areas, I guess, yet Africa as a whole, as a continent, there's still vast problems with food and water supply, so people are dying of hunger and water aid, and those kind of charities are doing a lot more. But I don't understand why Africa is producing so much food for us, and we're eating so many out-of-season foods. And again, and the plastics in the sea problem with the microparticles and whales are beaching with stomachs, and all the fish and the sea mammals are being beached with stomachs full of this food, and the island of plastic that's going around in the mid-Pacific. These are somehow very difficult problems to crack, and they seem to be joined up because the production seems to be joined up to the problems.
Thank you for that final comment. We'll make that a final comment, I think, because but would you like to say anything to that comment?
Yeah, no, these are very, very valid points and arguments as well. You know, that's always a big debate going on, that plastic packaging prevent food waste. Because we wrap the the food products, so the shelf life of food increase because of the plastic packaging. That was the original idea why they packed. But plastic getting a problem now we need to figure out what other kind of materials. That's where the circular design comes in, that what kind of materials we start using. For example, now more and more, the natural food products are used to wrap the food products itself, which was traditionally being used. So instead of using plastic, so we need to figure out. That's why the researchers come, their role comes in, that we need to find those alternative way of doing things, the packaging, so that we can still keep the shelf life of the food product longer instead of using the non-biodegradable plastics.
Thank you. Yeah, thank you. I think that was a really intelligent and considered comment, because when you were saying these things are somehow related, I think there is a lot of research challenges now talk about actually trying to solve challenges that run between the Sustainable Development Goals, because the Sustainable Development Goals are somehow siloed, and that's really what you're saying, and I think you're absolutely right. And I think those are, there are some intractable challenges, or seemingly intractable challenges in between there. Anyway, I'm going to say thank you very much. Thank you to our three speakers. Let's give them a round of applause.
So, guys, fantastic. I don't know about you. I thought they were absolutely fantastic. I found the talks really interesting. So next week, we have another talk in this series, looking at these digital issues, as we do the week after. It would be wonderful if you could come along to that. The conversation will continue now. If you want to join us outside, we have some drinks and some nibbles. I think what we should take with us, what I always like about these public lectures, is they don't necessarily provide solutions or answers. What they give us are things to think about. And those things that we're thinking about are great to talk about with other people, particularly over a glass of wine and some nibbles. So thank you so much. Thank you.